All right, welcome to the stream. Hope it's okay for everyone. And we're doing it a bit early today because I have a meeting at 9 o'clock. So I'm hoping to be done by then. I think we'll give this 2.5 hours or so. Anyway, let's get started. So, it doesn't look good in the sense that not a lot of people have finished the first part and not a lot of people have finished the second part. So maybe we'll be lucky. Maybe we'll be there. Hi, little Lenny. Welcome to the stream. And let's see what day 12 is all about. Wait, I thought you were saying hot springs. Hot springs. Hot spring. Lava shortage. Oh no. Oh. This would be good in Iceland. Whoop whoop, day 12 indeed. Let's see. Many of the springs have fallen into disrepair. The condition records of which springs are damaged are also... Oh no. In the giant field just outside, the springs are arranged into rows. For each row, the condition record shows every spring and whether it is operational or damaged. This is the part of the condition record that is itself damaged. For some spring, it is simply unknown whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list is always accounts for every damaged spring, and each number is the entire size of this contiguous group. So start forward, never without before, never to 2. Okay. The condition records are partially damaged. Some of the springs condition are actually known, for example. Equipped with this information, it is your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. In the first line, there is exactly one way separate groups of 1, 1, 3 broken springs can appear in that row. First 3 springs must be broken. Must be broken, then operational, then broken. Making the whole row. Okay, second line is more interesting. Could be a total of... Okay. Last line is actually consistent with 10 different arrangements. Because the first number is 3, second is backwards. First and second question mark must be dot. However, the remaining horizontal spring conditions I mentioned raise. Let's see what is happening now. Alright. This is a day of Stakistud, indeed. Santa Clauses are coming to town in Iceland. I got a apple today. Not bad. Nandi got some Icelandic chocolate. We'll see what Gilead will bring. Okay. 1 arrangement, 4, 1, 1, 4, 10. Okay, so it's definitely doable per row. So let's just copy this as the example. And let's copy back the split on function. I don't think we used it here. Maybe we used it day 9. I'm not having like an immediate idea of how to do this. I mean, that's just one way to kind of generate things and then just checking. But oh my god, seems like that would be very bad. But at least we can try for the example and see, you know, main where. Okay, we got the split on function here. Okay, let's say language GT 2021 parse example. We are going to get so it's really each row. So we're not gonna generate the we're just gonna have the contiguous blocks, right? Let's say string. Let's just start with, you know, go through a list of string comma list of ints. Okay, parse example equals parse map parse row, where parse row stir equals a where. Okay, so we're gonna split on, we're gonna have the stir st and the nums. We're going to split on the space, split on space, and then we're going to just return st, and we're going to return read at list of ints. We're gonna just add some parentheses around it. It's a bit hacky, but it should work. Main equals to read file example into print a parse example lines gto day 12 day 12.hs and time because it's only going to be 2 strings. It's not actually not like a pair. Prelude.read no parse. Let's do trace show id import debug.trace. What is different parse? Okay, so split on does discard the initial number. Okay, so we got the so we got the thing. Now let's see what we do now. So solve row string list of ints. Let's see, solve row of empty is equal to 1. Okay, there's no more numbers, and we're just doing 1. Solve row. Okay, if we have a question mark at the start and we have a 1 here, RN, RS, this is just equal to, so then we just do the dot. Let's see. That is just equal to solve row, drop 1. Actually, yeah, because the next one is either equals solve row RS RN. Okay. Solve row. So this should solve the first row, okay? So we're just gonna say print. I mean, it's gonna crash for the second one, but that's okay. Now let's see, we're just gonna drop the periods, right? Dot. RS, RN. Solve row, RS, comma, in RN case, so we're gonna say all equal to this. So first we're gonna H is equal to, let me say, H rest is equal to split at N RS, and all equal to this H is equal to solve row rest RN. Okay, I think this solves the first one at least. Because that one really only has one interpretation. Let's see. Let's see what we can do here. So we always reduce the RN. So if there is an RN, let's see. Okay. But why does it return 1,1,3? It's just because I'm doing this. Right, and I need to actually map and print. So first one is solved. And the second is solved. So I got the because it might be right. So the two question marks might be different fillings. Maybe it's just easier to replace and just generate all the options. That's going to be difficult though. Let's get the input actually. See how bad it's going to be. That is a lot of input. So then anyway, we should generate all the solutions. And just check them. Let's write that. Okay, so that's gonna say so let's just say check. And now let's go back here. And check, we write this. So we're going to say, we're going to take in a string and we're going to generate this list of ints, right? So check, empty is equal to empty, check. Axis is equal to span. Let's see. Where so this is going to be hashes and h's, and this is going to be rest equal to span equal Also, specifically doing this like with strings is going to be bad, right? So let's not do that. Let's do parse example. It's going to be a list of bool. Okay. Map. It's going to be not a bool. It's going to be yeah, let's just call it a list. It's going to be data entry is equal to dot hash unknown where eq show word. It's going to be a list of entry. Okay, and where to entry start to entry hash equals hash to entry equals unknown. Now let's just check this again. Unknown dot hash. Let's not do the example just yet, just do the check. Okay, so now we're gonna say check arrangement of a list of entries to a list of ints is okay. So hs is gonna be span is equal to hash of x's. And then it's going to be length hs drop while equal to dot rest. Right, and then we're gonna do now let's map element dot first on these examples. And let's see, we're getting the right ones. 113, 1316, 411, 165. Okay, and we just have the, let's see, where x's prime is equal to this. And we just have the issue here that, let's see, if null hs then x's prime, else length hs colon x's prime. Okay, so now we've generated all of them. for the check. Let me see where was the check? Oh, here. 113, 113, 1316, 411, 165, 321. Okay, so now we're going to generate the list of options. It's going to be crazy. Okay, options makes a list of entries. List of entries. Okay. Options. So if you have a dot, options of empty is empty. Options of dot something is equal to map dot options hash x's is equal to map dot map hash options x's options unknown. However, x's is equal to so then we're going to say where rest is equal to options x's, and we're just going to say dot rest and hash rest. We just generate a list of twos. Right. Okay. This is gonna be super. It's gonna blow up, but thanks to laziness, it might not be that bad. Let's see. So let's just say part 1 is equal to string to let's just make it string to int. Part 1 simple. Part 1 simple is equal to str. Okay, so let me see where let's just make it do one thing at a time. Map parse example, map parse example, map parse example. Okay, and let's just see where entries parental check is equal to parse example strip. Let's just see if this compiles. I feel like there's a compilation error somewhere. Okay, there's no error. Now we are gonna do a very crazy thing. Options, entries, filter, let's see, filter equals check dot arrangement dollar and then links. So laziness might actually just make this work immediately for us. Let's see. Map oh okay, let me see. Price show ID. Okay, there's unknown. So it's 113 at least. Let's let's focus on this first one. Okay, and now let's okay, I got right. It's because I'm always mapping and then I just end up with an empty list. So they should actually be like this. Okay, I got one there. Now let's not trace anything. And let's see how long it takes for all these options. 14111410. Let's see, 14111410. Okay. And the sum of this print.sum is indeed 21. Let's see. I don't think, maybe it will work for the input. I think it might work. Okay, it worked. Hello, Yash, Valo. We're doing We're doing day 12. We just did part 1, I think. Boom, part 1 done. Using the extremely naive way of just generating all the options. Which is, that's okay. At least we did part 1. Oh, they were folded up. To unfold around each row, replace list of spring conditions 5 copies of itself. Ooh. Okay, that's kind of crazy. This will not work with our approach, I think. Let's let's just do the unfolding manually. Unfold string to parse example. Okay, part 1 simple. Part 2 simple is of course just entries prime, check prime, check is equal to concat replicate 5 check prime and entries prime. Let's see how long it takes just for the example. How are you, Yash Valo? Nice of you to join the stream. We are doing day 12. We finished part 1 with our extremely naive solution. Of course, the trick here is that we would like to. So now we're just generating all of them, and then we're just ignoring the information, right? We could probably memoize, right? You say that, like, if you have a block of 3 question marks. Yeah, for the It's not even finishing for the example, right? And let's see. Might also be eating up all my memory. That would not be good. Let's cancel this. Yes, exactly. Let's see. Okay, that didn't work. So we need to be smarter about this. I like the fact that number 1 worked though. That was kind of nice. We need to replace a list of Spring conditions with 5 copies of itself, separated by question mark. Okay. So it's not even just this one, it's gonna be question marks as well. How do we deal with this? I feel like if we solve the beginning of the string, then we can kind of take it by group. Let's see. Let's do that for the example first, right? Or for the part 1. So, this is actually concat. But let me just make sure to generate this correctly. And then I'm gonna do intersperse with this from data list. Okay. Then we have the checks and entries correct. Okay, so let's see. If I have the 1 there, What are the possible lists I could generate? Let me see. Instead of doing map, let's just do map M. Instead of taking this out, let's just see how far it is getting actually. Just not compiling it even. That's not good. Mm-hmm. Okay. Okay, it does find the first one quite fast. But then it's doing 16,384 arrangements. That's more than the entire... that's more than the entire input. Mm-hmm. So the problem is I'm not really getting any good ideas here. I don't know how to like how to proceed, right? Maybe we can kind of recurse somehow. Let's tie these together. So if I'm generating one, if I'm looking at one, let's look at it this way. Okay, part one. They're not simple anymore. First of all, we can drop while it's dots. Okay, because dots don't matter in the beginning, so until we reach a question mark or a go. Dot. C's equals go RSCS. Go check. There's not a dot, right? Until we get a dot. We just go. We're just gonna return that to just see what happens. We're not doing the input anymore. So we always have an unknown or a hash in the beginning. Okay, now let's I'll select this. Span not equal dot a unc comma h's unc and h's rest. Equals, okay, and then we're just gonna say immediately, right, let rest prime is equal to drop while dot rest. Okay, we have unk and h's, and we have CS, and we have rest prime. So then we get 3 unknowns, and then at least 1 dot. And we can so how many objects can this be? So I just kind of want to just do this for all of them. Just separate them into the groups. So let's not do the check. Let's just separate them into some groups. Go entries. We're not looking at the entries. The CS is yet. Go drop while. Okay, and this is actually not gonna, we're gonna have it like this. We're gonna have it like go rest prime. Except of course, go of empty list is equal empty list. Okay, so this is two groups, and there's some number of dots between them. Okay, let's see what we can do here. Oh, I'm gonna put an alarm, by the way, so I don't miss my meeting. Let's see. Alarm. Scrolling. I have so many alarms. Yeah. I'm gonna stop 10 to 9 at the latest. Okay, so here we have the groups. Separated by dots. And we're actually gonna say this go and check as well. Just so we see what we're dealing with, let's close this window. So the thing is, now I know so I want to say that. So if I know all of them, so I can tell that this hash group here is this 3 here, right? And I know that these hashes here 1 1 are the. I know exactly. I know that these are both We're definitely onto something here, I think. Let me do this for the input. And just on, like, you know, take 10 lines of the input. We need to do it for all of the input. Just want to see if there's any help in like going backwards and removing, like would work in for the example, right? No, it's pretty much doesn't really help. Okay. Let's see. This is going to be some combinatorics, right? Like for this one, right? It's going to be exactly 2 ways that I can make one of these be let's see. Right. Let's write the selection one, right? We don't actually need to generate that. We just need to yeah, I don't know how to do this. I think. Well, let me stare at it a bit longer, and then we can see what happens. Maybe I should not split on dots. Maybe I should be splitting on hashes. Let's see that. Oh. Here I am just splitting on too much, I think. Let's see, what does the split on function do? Let's do split on keep. Which instead of it's like this. And we're going to say off, and if it's empty, we just do our empty if it got something. So we're going to be doing our so those. So split on keep. We'll split on keep. Hmm, 411 is split on keep is not working either. Let's go back to splitting on the dots. Splitting on the hashes, I mean. So I know between all these groups there is a dot. And I know that if it says 1, 1, there's at least one dot in between, right? How does the input look? Let me see. 1, 5, 2, 5, 3, 6, 10. It's never any huge number actually. It's always less than 10. There's 1, 10, 11. Most of them are 1 actually. Let's see. Select entry. Select. Now let's see. If I just have 1 unknown, maybe if I have n, ends, and n is not equal to 1. Now let me see. So I have 1 unknown, and I have a 1 is equal to just with just the hash and the rest. And if I have the case that I have ease and I have n and length es is equal to n, then I have just replicate n hash ns. So these are only 1 options. Welcome if you're just tuning in. I'm working on day 12 part 2 and it's proving rather difficult, specifically because I have no idea what I'm doing. Let's see, special case for 2. This is going to be either hash dot or dot hash. Now let's say select let's see if we have two unknowns, unknown and we have one in the front. Why I should learn Haskell as my first language. It teaches you a lot how to model data flow, I think. I really like it. Might not be like the most profitable way to go about it. You should probably learn Python or something because there's just a lot more material out there on Python. But Haskell will teach you a lot, right? So it's got that going for it, which is nice. Do 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 do. I don't know how to. I'm having a hard time modeling this. First of all, it was super nice if I could just see the threes there. Maybe I can like pre-process it, right? By saying, you know, there's only one possible solution. We can pre-fill in that solution. Let's do this more efficiently, actually. Span dots. And this is going to be a map. I don't know if this is any quicker. Could be. Doesn't like it though here. Let me see. Let me see. Did this make it any quicker? No, it's still 4 seconds. Doesn't help with a little quicker with optimizations, but it's not like it's super fast now. Maybe I can kind of generate the options, and instead of generating options and checking, I can kind of use the fact that I have the entries. Let's do that. Entry. Int. Okay. Probably doesn't make sense to do this way, but let's see. And now for the docs, we definitely just take a while. So I just want to take the so if I'm going down the dots path, then I just take dots until I can't. Oh. Now let's see here. This should be rest, right? I should have it the other way around. Entry, and we have a CS, and then here we have so what I'm actually going to do is if CS is empty, and I have axis, I want to see a case all, so then the rest of them all have to be dot. If all dot axis, then axis else. Otherwise I don't want so then we kind of bail out early if we have the checks are empty. Options with check. Okay, and if we have any here, but this is empty, then we're just going to return empty, because then we're missing some hashes. Okay, then we take all the dots until we don't have any dots anymore. So then we can assume that the previous one we hit was not a dot. Okay, so then we write that case. So say options, we check CCS, the axis is an axis, and we say okay, so now we are gonna, so the previous one was dot. So now we're gonna say non-dots rest. Span not equal to dot axis. Okay. Is equal to, so case, let's see. Now if so if we took until we didn't find a dot, and we if Okay, so if C is equal to length ND, right? Then we just, it all has to be hashes. Map replicate C hash onto options with check CS rest. Let's just do here else error show CCS and access. Now let's write here instead of this, let's see options with check unknown dot hash. Okay, we're hitting it right away. Let's see. If we're hitting a hash, if we hit a hash, so if we hit a hash, then the next C have to be hashes. It's just like that. Then we just do rest is drop C minus 1 axis. Because then the preceding one was a dot, and then the next C minus 1 has to be hash also because we're in a hash group. Okay. Options with check. CS rest. Okay, now we know that we're in the case. We have unknown. We have access. Let's see, in the year. Actually, we should have this axis at. We can drop C here. Okay, let's see. And now we're in this case, the select case again. Except we're looking at the case. And because we have these empty lists, we've kind of already filtered out a bunch of impossible cases already. So one option here is to make this unknown into a hash. So we would have and we would do, if we make this unknown into a hash, we have to have C hashes. So then we do map replicate C hash, where C hash is equal to replicate C hash. Let's see, we map C hash, C hash, and then so we can either make it into a dot. Go. Okay, RS. Let's see, do that. So we can make it into a dot. And if we make it into a dot, we just do let's option split check CCS RS. These are the options if we make it into a dot. or we make it into a hash, and then we need to make C hashes. And then we are saying options with check. CS. And actually drop scene when I was 1 hours. Okay, so now it's saying hash dot so these are the options. So for the first one, it's giving very strange stuff. So it's saying let's just see what it does for the first one. Okay, we're supposed to put C's and we don't get any C's and it's empty. Now we can do we're doing the dots. Okay, and if we see the hash, then we say, let's actually say hashes rest is equal to span is equal to hash axis, and then we're just going to check here if length hashes is equal to C, then else. let's see here. And the rest. What is axis? Let me see, just C is axis. Okay, then I'm looking at 1 and 3, and it's not 1, so then it's okay. I think I have to do map. We drop C minus 2 actually here, because then the next one can't be a dot. Okay, let's see. Okay, let's take it back here. Error axis. Okay, so I'm looking at an unknown. Maybe something's wrong with my like the empty product thing. Okay, so I'm looking at unknown here. Let me see. Axis. Axis, let's see. B, A, B, X. Axis prime is going to be just do AS, BS. It's going to be split at C axis. So if I can split at C axis, Now let's see here. So case BS of if this is hash, then we are then we are if this is hash, then we just want to do, so then this unknown has to be a dot, because otherwise we'd be going over. So then we do map dot over options with check. CCS RS. Now if it's a dot, then we map where C hash equals replicate C hash, C hash, oh, then we do C hash, and then we don't take the C, but we are just taking we're taking the BS. BS. Now if it's an unknown, then we have two options. Okay, first we have to actually check if not any equals dot in is else. Let me see. If any is dot in AS, then we're in an impossible case. Else, they're all either unknowns or dots. So then we check if we have to make this into a hash or dot, but if we don't, then we can either make it into a dot, map dot, let's say is dot, so the is dot case is this case. Is hash is this case. Oh, sorry. Then, so this is the is dot case. Sorry. Let's just see here. is dot else sorry, let make dot equal to this, make dot make it hash is equal to this in. So if we have to make it a dot, we make it a dot. If we have to make it a hash, we make it a hash. If we have the option to choose, we simply say map dot, then we can choose both. Okay, make dot comma make hash. Okay, we can actually we have to concatenate these. Okay, now let me trace a bunch of stuff here. Let's see. AS, BS, C, axis, RS. So now I'm looking at the unknown. Okay, let's see. Trace show both possible. Okay. Trace show has to be dot, make dot, trace show has to be hash, make hash, trace show both possible. Let's make this case simpler. This is just going to be map dot over let me see here. Ratio. Ratio ID. Let's see. Now we're trying to figure out what is going on here. True. Okay, so if we hit the empty case, then this works out, okay? If all of the ones that are left are dots, it's fine. Okay. Here we have a trace show hashes left CS. And we just return the empty list. Hashes left. Let's see. So I think this will work. Ding, ding, ding. I think I'm screwing up here. If yeah, this is a case I'm screwing up. I think this one is okay. Or I'm making the choice. But it's after I made the choice, and then I'm in the case where Okay, so I can't be in this case unless there was a dot immediately prior. Because otherwise, I see, if it's a hash, I will always make it a dot. Okay. So if I see a C, then I can see here. CYAS BS, and we're just gonna split at C axis, and then we're gonna say if any equal to dot, and then we want a if n equal to dot as, then it's false. Okay. Else case bs of so if we hit a hash, then we are in an impossible case. We hit a dot. Well, then we're in a great case, so then we just keep going. Options with check CSBS. However, if we hit an unknown, we have to make that unknown into a hash, into a dot. Option check CS unknown BS. Unknown access dot UKS in line 50 there's a non-exhaustive patterns in case. Okay. Right, and if it's empty, then we are also going to be empty. If it's empty, we need to make sure that if length as is equal to C, then otherwise it's not possible. So what I want to be getting out here is all the valid assignments to okay, sorry. The problem here is that, okay, I should be doing like this. Map as map as Okay, dot hash hash dot hash 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 and hash dot hash dot hash hash. Okay, so we're almost there, but this first one is wrong. There's something wrong with this make dot cache, I think. Trace show ID. So hash hash dot hash 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 and hash dot hash hash. Yeah, exactly. So in this make dot case, okay, but that's actually because trace show ASBS. Unknown dot hash hash hash. So 113. Okay. That's basically saying, okay, I made the initial one dot. Oh, I forgot to make map. Then I made the initial one dot. So if I make it hash, okay, make hash. So this one is make hash, but what I want to do here is I want to say a map c hash to options we check CS same as above, right? UKS and actually like this dot UKS. And then we get the right one. Okay. Let me see. Trace show. Let me just see one more thing. If VS is empty, then if length AS is equal to C, then C rehash else, just to cover this case. Okay, and so now we're creating all of these, but part 1 is actually going to be length. So now we're a lot smarter about how we do it. Let's see if it pays off. First of all, let's see if it actually works on the other ones as well. 1 1 1 4 1 1 2 8 1 4 1 1 4 we're not quite there, but we are moving forward. Ding, ding, ding. Okay, let's see what we can do. I'm gonna, work for like half an hour more, and then we will see. Let me just check what the time for this will be if we make it correct for the input. Okay, so it's a lot faster for the input. And then I don't want to be doing this if it's going to turn out to do not help at all. Let me see. So how many does the input have? 1000. Let me see, this was not done. Run, wait, day 11. Let me see. Zip width. Part 2. Map M print. It's actually going to be 1. Okay, it's going, but it's giving 0 for some of them, which is strange. So in some cases it's not counting. And then for number 12, it's just crazy slow. Okay, so it's not really doing it for part 2. Let's see for the example. One 2,500. So there's something I'm missing that's providing a lot of provides a lot of them. Okay, so one works. So it works for one, 3. It works for 1, 3, and 4 for sure. Because it works for both for the ones. So it doesn't work on the other one. Okay, let me see. Let me see. If length AS is not equal to C, or any dot, then one four one one two. I think okay. Let me see. Okay, if I'm looking at a hash and I need to get, I mean this is correct. Okay. Now if I have any left, just make this simple. No, I mean, I need to throw it out if I don't have, if I have any. If all equal to dot x's, then if all is actually not equal to hash, then replicate length x is dot. That's the mistake, I think. 141 to 11. One four one one 210. Let me see, what is the last one doing? Map part 1. Let's see here. We reverse the lines. And we take 1. And we don't print. We actually print out the possible entries. Oh. Oh, sorry, I was messing with the wrong one. Okay, and we are going to say here, take 1 dot reverse lines. And we do here instance show entry where show hash equals hash show unknown is equal to question mark. This is the last one, okay, and it always has to be hash 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 and then dot, and then it seems that I'm doing it in the exact opposite order, but I can do that, flip that order by just flipping this. So hashtag dot hash. Okay, that one is there, and then there's 2 dots, and then 3 dots, and then 4 dots. Okay, and then 2 hashes. There's this last one that's wrong. And that's if I make a dot. And it's because wait. if the last one is an unknown, okay, it's not like that. Okay. Okay, let me see. If length axis is less than or equal to C, then we don't do this. Else, let ASBS what am I trying to do here? I don't want to make the hash always want to make the hash. I want to make the next one so okay, so it's just the same as this one. But then it is like that. Okay, doesn't matter. Then I add hashes in front, and then I go to the 10 more minutes. I don't think we're gonna solve this in time. Okay, there's one case too much, and there's one case too little. This last one is not possible. Let's just do we check CS and axis case sum CS is less than is larger than length. That got rid of that case. Let's see. Oh, there are just unknowns not being replaced. Lovely. So one works. Map. Part 2. Links. One four one one two 10. 1 4. Okay, but this it should not be. One 4. So I'll replicate it with dots. Here I split at C. This should be replicate C hash, I think. Let me see here, where C hash is equal to replicate C hash. So it's dot, we do C hash, C hash, C hash. Okay, so now we've got rid of the question mark, and it's still giving the correct one, except not for this one. So to make this a lot faster, I could just compute the numbers directly and not all these, not make all of them, right? So then here it will just be like 1 and 2 and something like that. Okay, but now we are looking at we're gonna take part 1 of the head after we drop 5. No, we drop 4. Okay. We're getting 2, but we should be getting 4 because there are 4 possible ways to assign a dot there. Okay. So everything is correct except see, then we're doing trace show ID UKS here. Okay, and let me see. I gotta stop quite soon. Make UKS hash where this one is actually mapc hash. I can actually just do dot colon drop one BS. And then I don't need to look at it. Make hash and make dot. Okay. Let's see what it gives. Okay. Now let's see. We're gonna say here axis a trace show. Oh, let's just write it here. Trace show. I want to trace show here. CCS axis. Making dot hash both. Okay, so it gets that one correct. It would make the last one hash. making both. And let me just then write out what make hash was. Hash make dot. All right, I'm gonna wrap up very soon. Making hash, making both. Okay, so here it made both. Okay. Okay, so there it made it. Seems like make hash failed. All right, sorry, I'm gonna have to cut this for now. I have a meeting in a few minutes, but I think we're getting quite close, and I think if we make this, so now we're in like debug mode, saying like, okay, we're printing out all the lists, seeing what's happening, all like that. But what we can do later is that we can just make this return a number, right? Because you can see here, it's always just looping, right? So this is just going to be additions of numbers, right? Instead of returning the actual lists, which should be a lot faster. But okay, thanks for tuning in for today. I'm gonna do the meeting, and then I'm gonna start streaming again for maybe an hour and a half or an hour, depending on how long the meeting is. But thanks for tuning in, and see you later for a little bit more of day 12, and then we'll see how it goes with day 13. All right, thanks for today. Bye-bye. All right, welcome back to day 12, part 2. I took a bit of a break. I had a meeting, but we're almost there with this. I'm trying to figure out, I've added a bunch of annotations to try and figure out this last case. And it seems to be somewhere here where we are not quite generating. So for this case here, we just generate these two lists for this case here, but we want to generate, there's a lot more options on how to put the hash. For example, you could put the hash right away, right? But that does not seem to be happening. So let's see. So make hash, making both, right? And then like it makes these two, which it made in these two. That was make dot, and that was make dot again. And then this one we had hash for dot star hash star, and then these two options were made, right? So it made this one, and it made this one, but it seems to have not made one where it just says hash right away. So, okay, so what happens is we're in the unknown case. So we're not choosing hash here for some reason. Okay, so let me see. So why do we not choose it here? It's because oh, we end up with a wrong split. Interesting. I think if you end up with this case and you say hash, right, and then you have to make dots, right? Let me see. Making dot. So we never hit this making dot case. Let me see. Case BS of Why is that? So unknown case, okay. It's because so here actually we have to say make dot, I think. Let me see. Let me see, maybe make that here. Okay, now we get those cases at least. So it's basically saying, if you can't do it, I think maybe we should have it here also. Okay, maybe not. So basically, if you can't do it with the number of unknowns that you're considering, then... Alright, let me... move all these trace shows here. Ding, 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 ding. So now I get 4 here. Let me see. One, 4, 1, 1, 4, 10. Hey, Felix. Nice to have you back. Let me close all these tabs. Let's go back here. We're supposed to get 1, 4, 1, 1, 4, 10. So we're getting that. Okay, so we're doing okay this time with part 2. So I did part 1 earlier. I worked about a bunch of part 2, but it's taken a long time. Let me see, some map part 1. Map length. How long does it take for the input? So our first solution took 2 seconds. This one takes 33 milliseconds. Oh, and your postal answer was 6827. Okay. So we're not correct on the input. Too many left. Okay. But we are getting there. Let me see. Let me just see if part 2, how long that takes. Takes quite long. Let me see. Do we still? Yeah, there was some loop in it before. Where do you generate the possibilities? I did that before. So first I had a function that's called options, right? And this one just generates every single possibility. But that takes too long. So now I have another function that tries to generate possibilities, but with keeping the checks in mind. But it's not really working out because it doesn't. I mean, it works for the example. That's called part 1 simple. So let me figure out now, because it works for the example here. Let me see. Let's see. So we're gonna do let's read file input and imp_l, let imp_l equals lines imp. Let's actually just say then lines. Okay, so we're gonna do map length. We're gonna take in a line and we're gonna say length part 1 simple, part 1 L. So we're gonna say filter, filter, print filter, L length dot part 1 length of part 1 L not equal to part 1 simple L of imp L. Let's make this let not matching, and then we're gonna say print length non-matching. So this is good, right? We have like a reference implementation. Options with check, right? So options with check, let me just put it here. So then we're trying to say, okay, we have some options, we have some checks, and we're trying to simultaneously generate all options, but only options that are possible according to the check. And then we're using a lot this trick with kind of, we have empty lists that say there's no possibility of this, and then that destroys everything else. But now we have a list of things where it doesn't match. So let's just start print take 10 map L part 1 simple L versus part 1 length part 1 L of non-matching. Let's change part 1 simple to not take the length. So we can see the actual options and entry. Okay, let's just take the first one. Try and solve that. Ed. Then we're going to say map m print part 1 simple and m map m what's ln map. Good evening. We are making progress. Sun X sum dollar interleave 1x. I don't quite know what you mean here. Okay. Print nm. Some CS is less than length of axis. So this case is where it's Okay, let me try that. I still get some non-watching ones. Let me see. But it's good that we have a reference implementation, right? That we can draw upon. Yeah, that didn't change anything actually. Okay, this is even less. Okay, let's actually sort these. Okay, the first two seem to be fine. First three, first four are fine. And then the first four are the same. And that's basically where we assume the 2 is in the first one, I think. Yeah, it has to be in the first one, okay. Okay, we can actually drop. Because the initial period is the same for both. Just to make it slightly easier to understand. So I seem to get it right. Except we only make one choice here. Okay. Whereas here part 1 we choose to make this one dot, but we don't choose the part where like we make neither of them. For some reason. So we are missing some cases. Which is strange, right? Because okay. 2, 1, 1. So here we make 2 and then 1. So it's like it's not taking the option of not filling out this one. Which I think is there are no hashes in this entry, so it's all in this unknown thing. So the make dot, then we make it a dot. Which index is this, by the way? Let me see. So if I do make hash, let's see. But then I can't sort because I need to know which one I'm looking at. Okay, it's the first one. That's good. In part 1, Let me see, trace, show, CCS, BS. And we just want the head here. Trace, show, $. Right, now it printed everything for everything else. So 2 1 1 okay. Let's see, so we split at, so it's 2 1 1. Okay, we split at, so we split at 2 ASBS, and then there's no dot in AS, so we're doing case BS of, okay, and then it's make unknown. Okay, so it's just when the head is unknown, the next one is unknown. Yeah, so then we can make it it's a lot of output. Okay, right, okay, so I think this one is okay. So so for this 1 1, right, it is this question mark dot question mark. So if it's 1, it's a okay, I think the thing is we always make a choice. So if we see a dot, we should also actually make nice. So now there are no two that don't match for the part 1 simple and part 1 output. We just forgot that we could make the right decision there. Okay, let's see. Print some okay, now we get the right answer for part 1 on the input using our smart method. but I think it's still gonna be quite slow for part 2. See, example. Now part 2 is where we changed up the string. Let's see how long it takes for the example. A second. 525152. It does work though. So now okay, let's take this options with check. And so notice that we were only like mapping over, but we're never actually we never actually read the lists that we are generating. So what we can do is that we can take this whole thing and then just say we can make it into an integer function, right? Options with check, and we're going to replace that with calc ops. Okay, so we don't map over here, so this one just means we don't map. Okay, here we do 0. Here there's only one option. So this is actually going to be 1. Let's make it a list of ints first. 1. Zero, 0. Here we have, okay, it's just gonna be an int, really. 0, 1. Here we don't make anything, we don't map over it. And instead of we multiply. One. Okay, let's see how fast calc opt is. Read file example sum. Let's just do part 2 prime int, and it's going to be calc options, calc opts. Let's do part 2 prime here, and there's no map length. Let's just map part 2. Okay, we got some answer, and it does make sense. Because we're only multiplying and we only have 0 and 1. But if we get this right, it's going to be quite fast. Let me just see. If if it actually makes sense, or if it's still going to be too slow for the input. Okay, so even if we make it correct, it's still not going to be fast enough. Well, let's take and check. So here's really only one option. Should I do pluses here both? Nice. Okay, so this one is gonna work if it finishes, but it doesn't seem like it's gonna finish. Let's just see how fast it is for part 1. So let's check here. We're deleting. Oh, let's keep this around. For example, okay, now we're doing here part 1, and then we're just gonna do part 1, right? So for part 1, we can do it with this calc_ops function in 34 milliseconds. If we do it manually, otherwise, yeah. Ooh. But it's giving the... It's not giving the right answer. So it works for the example, the calc_ops function, but it does not work for oh, I changed something back. Oh, I undid too much. Good. Okay. So part 1 is quite good now, but it's gonna it's taking a long time on the input though. You see, I really thought making this would make it a lot faster. Okay. Let's see if this helps. I mean, it's giving the same answer at least, so I think this one is redundant. Let me see. Does anyone have any efficiency ideas here? I think because I'm just going through it and I'm calculating all the possibilities, right? So not generating anything. I could probably do some memoizing, right? Because I do think this make hash make dot, they sometimes do a lot of repeated work. So let me just keep minimizing this a lot. And one thing I'm thinking of is like we could have like shortcuts where okay, so what I want to check is So I can merge these two branches. Because this one is just gonna immediately drop, right? Let's see. Same here. I have a part of the whole journey. Can you do a short explanation of what the project is about and then a short explanation of what the current problem is? So we have these hot springs and they look like this. Like there's a map and it says, here's one group and here's another group of size 1 and here's another group of size 1 and here's another group of size 3. It says 1, 1, 3, right? To say how many hashtags are in order. But it's damaged. So what we get is we get these question marks instead. And now we have to guess or figure out how many different arrangements there are, right? So here you might have hashtag, so there's many ways to fill it in, right? So for this one, it's only one way. But for this one, you say this and 3, 2, 1. Like the first one cannot be a hashtag because the first group is supposed to have 3, and if this one was hashtag, it would have 4. So the first one is always going to be a dot here, but then there are multiple arrangements of the rest here. So what we're doing is that we are summing up all these different arrangements. And then what works great, we're just counting them all. But now the problem became a lot harder because instead of just being like this one, the first line becomes all of this, like all of the lines become a lot longer and the patterns are repeated. So everything's repeated 5 times. So it's going to take a lot longer to actually calculate. And I'm trying to get away with it by making like a tight loop and just counting make dot, make hash, make dot, something like that. But what I think I have to do is I have to calculate, like use probability theory, right? So there's a way to say there's this many ways to pick a card out of 4 cards if you have these many options, right? But then I would have to figure out exactly how many in some way. But so this one works, right? This solution here works. It's just not fast enough. Let me see. Let's see how far we get. So first we have to parse all of them. That takes some time. Okay, it's not even doing the first one. You see. Why is it so slow for the first one? Did I accidentally introduce a loop somewhere now? No, I mean, that worked for the... Let me see. It's just taking a long time to parse. Oh, sorry. I didn't comment out this sign. Demo. So it's 1,000 lines. And let me see. Let's just see how much progress we make. This 12th one here seems to be very... takes a very long time. Let me just memoize it. Okay, let's keep this one as it is, but let's rename it CalCorp's memo. Okay, this actually returns mem. CalCorp's mem CSX's case CS, X's map. I made it 2 times. If it's in the map, then return res, m. So here we're just going to immediately drop. We're not going to change anything. Okay. We can actually just, we don't need this loop here. Let me remove it here also. Yeah, you can see that number 12 just takes an amazing amount of time. So we really need to get around that somehow. Let me see, this is really the same case, right? Let's see. Right, it doesn't check anymore. Calc up to mem. So calc ops here mem. Calc ops mem. Calc ops mem. So we just do it directly all the time. Here we do comma. We're not really inserting here. It's just when we branch. That's really when we want to. When we branch out, we want to calc ops mem. M. Okay, make dot. We just do make dot, that's fine. Because then we're just in the loop. But if we do let I comma m prime equals make hash m make dot m. This is just a loop. Otherwise, in mhres in md res m prime m prime. We delete this in here and we say oops. Oh my god, sometimes this happens in Visual Studio Code. No matter. I just need to copy paste. Let I am okay. This is mh res, and then this is md res comma m prime is equal to make dot m prime in mh res plus md res m prime. And we need to have the where again here. And then this one is because it's calling a wrong function. Oh. Part 1 we don't really need it. Calc ops. But part 2 prime calc ops mem. And then first make hash m. It's not giving the right answer. It seems to be going even slower. Let me make it at least give the right answer. There's 1 and 0. Otherwise, it's you can find it in the map and it's correct. Otherwise, it's 0, m. Here we just drop. Okay. 0m hash 0m calculus CRS 1m. Oh no, calcup CCRS make dot m, make hash m. Make dot why is it giving the different answer? Ish. Okay, it doesn't even work. So, and it both doesn't work and it's slower. So this one is deleted. Okay, I need an even cleverer way of doing this. It's getting quite late also. Okay, it's really not doing this number 12 here. What if I delete it? Is it just that one that's super bad? No. There are more. I feel like if I know the solution to part 1, I can use that to solve part 2, right? Because we're going to take this string, right? And it's going to be the number of ways you can solve that. Let's see here. So it's 1 4 1 1 4. 1 4 1 1 4. It might also just be Let me try and do the memoization again. Okay, let me actually, before I do that, I'm just going to simplify this to be a non-dot. Okay, and then these will not be evaluated. In so if it's hash, Let's see, this is gonna be I'm just trying to join these two branches here. Not to make it faster, but just to make it easier to program. Case non.of. If it's hash, then this is supposed to be then it is this always make hash plus make dot, because if we make this so here it's just rs. Yeah. So this rs here, drop 1 bs, is the same as the rs here. Let me see. Okay, we get the right calculation there. calc up, say mim. This can also just be a loop. No need to do any drop whiles there. It's going to be exactly the same minus the function call, actually. Let me see. Maybe I can. If any dot as then I have to make the current one a dot. Okay. Otherwise, let's see. What if I make the current one a dot and then make hash? Let me see. If I don't do make hash here, I think maybe that's the one making everything go slow. What happens then? No, it's still quite slow. We split at C axis. Okay. And then if the first one is a dot, then we have a whole group that contains question marks and unknowns. I think we don't have to do it like one point at a time. So we're targeting this calc opt here. Let me see. Okay, even if I make that instant, we're still not good. What is going on here? Oh, I'm changing the calc to mem function. If, okay. Let me go back here and let's see. If I make dot 0 as an instant, it's super fast. Do make hash 0. It's also super fast. So it's because I am recurring twice here. So make dot, so instead of dropping 1, let me see, dot, if I made this instant, okay, then it's quite a lot faster. Okay, and we can make this instance because if here we actually know that we're gonna consume all of these and we are going to use replacement. Okay, so let me check. So if I have calc pause, so we have then we just have C, we have AS. It's fast. Wait, okay, so if this is if the next one is a dot, then these are all question marks, right? But it's not. Let me see, then we have to count the number of length filter is equal to unknown A's. No, this is just actually 1 plus make hash, right? Shit. That didn't work. Because I might not be using all of them. Let's see. Yeah, it's sad that this title loop doesn't quite work. Okay, 20 more minutes and then I am gonna go sleep. Okay, and now we're gonna say here calcups mem case okay, if any, then cache comma m prime calcups mem m prime. Okay, then make dot m prime, and then we do map.insert m prime Let me see here. We'll go. Okay. I need to insert this key and make dot m prime. Let r equals plus cache in, and then key is equal to cs comma axis in r comma map dot insert key r prime. Let's see here. R2 prime. Let's see what it does with a bit of memoization. Wow. It did work with memoization, as I suspected, because there were a bunch of the same copies. Let's see. Oh. All right. It took a long time. Total of 4 hours, 5 hours. But we did day 12, part 2, using memoization. Nice. Let me git status, git add day 12.hs input example. Status git commit day 12. All right, that's it for today. Thank you for tuning in. Sorry for taking so long. If I just kept on with the memoization, it would have worked. The trick was we needed to make it a bit more simple. K is equal to this. Let's just make it the same everywhere. Let me just make sure it still runs. Okay, good. A little bit of memorization, just add a map, keys, and because we're always kind of recurring into the same problem again and again. All right, that's it for today. Sorry for taking extremely long, as I said, but we managed eventually. Thank you for tuning in. All right, bye-bye.